Hello there, welcome to this video on Group 1 alkali metals. Now, where do we find them? You find Group 1 alkali metals over the left-hand side of the periodic table, unsurprisingly in Group 1. Now, hydrogen up there at the top doesn't count. Hydrogen is only there because it has one proton in its nucleus and one electron in its outer shell. It is a non-metal, and it's the only non-metal that's over on the left-hand side there. So it doesn't count as a Group 1 metal. Lithium, sodium and potassium, those are the ones that you should certainly be aware of. You might have heard of the other ones, rubidium, cesium and francium. Now, there is a pattern to the group 1 alkali metals, and that is that they get more reactive as you go down the group. That's a trend that occurs in these alkali metals. So lithium is the least reactive of them all, and francium is the most reactive of them all. And to understand why this is, let's have a look at two examples. Let's have a look at lithium and cesium. Now, all group 1 elements have got a single electron in their outer shell. That's why they're in group 1. And if you've seen my video on bonding, then you'll know that all atoms want a full outer shell. And group 1 metals achieve this by losing that last electron, getting rid of that outer shell, and relying on the next one to be full. So that's how they get a full outer shell, no matter how big they are. Now, so what they want to do, group 1 metals, just to recap, they want to ditch that last electron. Now, what's in the nucleus of an atom? We've got protons and we've got neutrons. Neutrons are neutrally charged and protons are positively charged. So the overall charge of any nucleus of any atom is plus. And these electrons have negative charges, and they attract. The plus attracts the negative, and that's what keeps it spinning around. It's kind of like gravity. It's kind of like the gravitational effect of the Earth on the Moon, which pulls the Moon in and keeps it spinning round and round and round. That's what happens with these atoms. Now, look at the distance between the plus charge of the lithium here and the minus charge of that last electron. It's not very far. Now, what that means is that final electron will be held on fairly tightly. Look over at cesium. The final electron is a long way from the nucleus. Now what this means is it will fall off much easier. The plus charge has not got so much of an attractive force on that minus electron, so it will fall off much easier. And that's what makes cesium react much easier. There's also another thing called electron shielding. All these other electrons between the plus and the minus of the last electron, they interfere with that charge. They diminish the power of the plus to hold on to that minus charge. So this electron shielding also has the effect of weakening the electrostatic force between the plus in the middle and the minus on the outside. And the upshot of that is the final electron will fall off much easier, which means cesium will react much easier than lithium. And that is why alkali metals get more reactive as you go down a group. Let's have a look at some reactions in water. So here you can see some properties of group 1 metals. They have a low melting point and a low boiling point compared to other metals, compared to the transition metals. Look at cesium here. It's got a melting and boiling point, or a melting point, of about 30 degrees C. Really, really low melting point. Other properties, they're soft. You can cut them easily with a knife, unlike transition metals, which tends to be hard. They have low densities. You would have seen in that video that the alkali metals were floating on water. They do that because they have a very low density. They're reactive. You saw that in the video just now. They effervesce. They produce a lot of gas, of hydrogen gas, very, very quickly, and sometimes they'll even explode. The group 1 metals are very reactive. They form metal hydroxides. Let's have a look at that in a little bit more detail. Lithium introduced to water. Lithium, there's the word equation here and the symbol equation here. It gives you lithium hydroxide and hydrogen. Now, as we know, hydrogen goes around as H2, but what you get is you get this lithium hydroxide. Now, our characteristics of hydroxides is that they're alkali. They have a pH greater than 7. And this is why the group 1 metals are known as the alkali metals, because if you react them with water, you get an alkali, you get an alkali solution. And if you were to do this, if you were to drop lithium, sodium, potassium into water, watch the reaction take place, and then drop universal indicator solution into it, it would turn, well, can you remember? Can you remember what an alkali solution would be with universal indicator solution? Well, it goes a kind of purpley colour. So that indicates that we've got this lithium hydroxide present. So here's the reaction. I wonder if you can balance it. If you want some practice at balancing an equation, then pause the video here, write it down, have a little go of it, and then unpause the video. So the balanced equation is 2 lithium atoms with 2 molecules of water gives you 2 molecules of lithium hydroxide and 1 molecule of hydrogen. So all we need to do now to complete this is to add the state symbols. So there we are. S is solid, L is liquid, G is gas, and AQ is aqueous solution, which means dissolved in water. So do you remember how to test for hydrogen gas? So here we've got a test tube of hydrogen, and if I introduce a flame, you should hear a squeaky pop. Now, another characteristic of the group 1 alkali metals is that they produce a characteristic colour when you burn them. So we've got lithium here, gives you this vivid red flame. Sodium produces a yellowy orange flame, and compounds of potassium are going to give you a lilac flame. You need to know that for the exam. They could ask you that question: what colour do the different alkali metals produce? The reason they do this is because when you give them the heat energy, that final electron jumps up to a different shell. It jumps up to a higher energy level, and when it jumps back down again, it gives off a photon of light, and it gives off these photons of light at specific frequencies, which give you the different colours. You see a similar thing with the aurora borealis and the aurora australis, the northern lights and the southern lights, where you look up into the sky and you get the greens and the reds. This is because ions from the sun collide with the atoms, knock that final electron up into a higher energy shell, and then when it jumps back to where it was before, it releases these photons of light. So just remember that you get red with lithium, you get orangey yellow flame with sodium, and if you're using potassium, then you're going to get this nice lilac flame. So there we are. That's the alkali metals. Thank you very much for watching.